Hello, hello. How is everybody? So I'm going to jump right into it. This is day 12. We're going to be talking about covalent bonding and covalent Lewis dot diagrams. So we've been talking a lot about bonding and electrons and Lewis dot diagrams. We've talked a lot about ionic compounds and how to draw their Lewis dot diagrams, and we're going to practice those in the warm-up. And then today we're going to focus on covalent Lewis dot diagrams, which have a different set of rules that we're going to talk about today. All right, so today's assignments include the covalent Nearpod, which will include the warm-up and the notes for today, which are pretty short. These are due during class. And then I've got a video quiz, which is our second video quiz. It's called Drawing Lewis dot diagram or Drawing Lewis dot structures for covalent compounds. I want to say it's about 15 minutes, so it's not too bad. And I didn't put too many questions in there. Recent assignments include the writing prompt, which was a test grade. We did that Monday and Tuesday a while back. I think the week before the snow week, essentially. So Monday and Tuesday. Let me look at the calendar here. So let's look at our calendar. And I'm still missing some of these, and this is a test grade, so this is going to bring your grade down a lot. And it's not really that challenging. I need you guys to write 5 sentences on the writing prompt. So answer the questions that are posted. So if you look in our calendar here, this is this week in yellow. Next week is in green, and that just gives you an idea of what's coming up. We are looking at a Unit 6 test before spring break. All right, so we want to finish up this unit, and then we'll start the next unit after spring break. So we've only got 2 weeks left until the end of the quarter. So if you guys are falling behind, you need to kind of start working on catching up. So Monday the 8th and Tuesday the 9th, we did a writing prompt in class, and this was a test grade. So let me click on that and talk about it for a second. So if you click on it, I'll go student view. So students are complete this during class. It's a test grade. So there's a video review of the concept. So if you click on that and watch this video, it's basically me going over everything in the writing prompt. Okay, you can see me there with my beautiful mask on. Although, why does it say? Let me see. There we go. Okay, so now it shows me. And so, yeah, that's a video of me going over it, which is nice. This was actually live during class, which is kind of cool. I needed to go over it during this class period. I think this was 4th period, and I just went ahead and did it live during class. So watch that video and then answer the questions. Again, all you need is 5 sentences, and it's a test grade. So it's an easy test grade. All right. What else have we done recently? Ionic bonding classwork. So we need to talk about that again today. So let me click on this, and let's look at it. Ionic bonding classwork does involve some steps, okay? So what we need to do is go to the assignment here. Let's see, ionic bonding classwork. And here's the instructions, okay? So let's go through these. So here's the Google document. So let's open that in a new window. All right, so what you're gonna have to do, guys, is go to the Chrome Web Store and go to the top link that says Chrome Web Store. So we're gonna go to Google, just Google. We're gonna type Chrome Web Store, click enter. You're gonna click this first link. All right, and then up in the search box, we're gonna type Cami. And it doesn't actually show up, or maybe it is right here. You can click on it or click enter, and then it's gonna be this one, purple, Cami for Google Chrome. We're gonna click it. We're gonna click add to Google Chrome, add to Chrome. It's gonna ask you this, add extension. It's gonna say checking, and then it says it's been added, and now it's up here. Okay, so that's our first step. All right, now we're going to click on this icon up here. This one right here is the one it's talking about. Click Cami for Google Chrome. Okay, so what we're going to do is open this document. And let's see, I think it should make a copy of it. Can we make a copy of it? No, we don't want to share. Let's click this link here. We're going to go to Cami. We're going to click it. And then what you need to do is locate your document. So what I could do here is I'm going to download it. So I'm going to download it. It's going to put it in my download folder. So what I can do here is I can go here. You can open it from Google Drive. So if you got a Chromebook and you don't have like hardware or local hard drive space on the computer, and you just have virtual Google Drive, then you can use that. But I'm going to open it from my computer. I'm going to go to my downloads. There we go. I'm going to click it. Click open. It will open it. We're going to say new copy. It'll make me a copy. Okay, then I'm going to fill it out. And if you look in here, the answer key is in here. So if you go here, I believe the answer key was in here. Let me see. Locate your document. So this is what it'll look like. We're going to edit it, then we're going to share it. Maybe I have to add the answer key in here. I've got an answer key. I've just got to add it in there. So I'll put that in there. So copy the answer key. And then, so you're going to write on this, like literally. So go to the drawing. You can pick whatever color you want. And you're going to draw your Lewis dot diagram. Okay, where's my eraser? There we go. Erase. So for this one, I would do K with the plus, and then fluorine with the minus, and then it would have 8 dots around it. All right, and so draw just the first 10. You don't have to do, actually, is there an undo here? That I don't know. I don't see an undo. What about, there you go. Okay, so if you hit Control and Z, it'll undo. So if you go, I just want to do these 10, okay? We're not going to do these 10. So just kind of cut it in half, okay? And if you look at the answer key, I've got most of these done. I think there's 2 of them left for you guys to do, okay? All right, when you are done, we're going to go to this share symbol here, share document. You need to upload it first. So we can do either one of these. Upload to Google Docs, Google Drive, and then here's your link. So I'm going to hit copy. So you copy your link. This is your completed classwork. Now you go back to the assignment on Canvas, go up to the submit assignment button, and submit assignment. So you can do a text entry or a website URL. So copy and paste it there, Control V or right click and paste. Get that link in there and then click submit assignment. And that is done. Okay, so that's our recent assignments. I want to make sure that you guys are aware of those. Okay. All right, so here's our warm-up. This page has got just the all the questions, so all 5 questions. And so what you guys are going to do on this warm-up is you're going to open the Nearpod. So if I go here, I'm going to go to my Nearpod. You're going to type in your name. Click join lesson. Okay, you're going to put your name here. Click next. Oh, click submit. Don't forget to click submit. All right, and then here's just a slide. Here's just a slide. Now here's the warm-up. So what I want you guys to do as you watch this video, complete the warm-up. So this is going to be hydrogen with the dot. Okay. And now how did I get that? All right. So hydrogen, if you look on the periodic table, hydrogen has atomic number 1. And it's in group 1. All right. So group 1, which means it has 1 valence electron, 1 VE. So it has 1 valence electron. And so what I'm going to do is I'm going to draw a picture, and I'm going to put that 1 valence electron there. So I put the symbol for hydrogen, which is H, and then I put 1 dot. Okay. And that's my answer there. So if you want, I'll put a box around this. So there's my answer. All right, hydrogen with 1 dot. All right. Make sure you hit submit, guys. Okay. I see even I'm forgetting. So make sure you hit submit, okay? Because I will grade these, okay? All right, now draw this Lewis dot diagram for hydrogen -1 ion after it loses an electron. So here is what we had. Ew, I don't like that color. Go back. Ew. So here we go. Hydrogen with 1 dot. Now we're going to have a -1 after it, and this is actually gain. So it's going to gain an electron. So we're going to add an electron to here, which means, there we go. Now it's got 2. Now it is going to have a -1. So let's draw this down here neat. H with 2 dots and a -1. So there is our answer. H with 2 dots and a -1. Now the other thing that hydrogen can do is it can lose an electron. Okay. And let's draw that. Actually, let's draw that back here. Let me go back. So hydrogen when it loses an electron. So let's go back and think about this. So if I have hydrogen, let me erase some of this stuff here. Okay. Where's my... So if I have hydrogen with one electron, so that's the Lewis dot diagram for hydrogen as a pure neutral element. Okay. Now what we're going to do is we're going to remove that electron. Shoop. Pull it off. And so now it's going to be H. It's going to be naked because we lost that electron. That electron has been removed. And since that electron was negative, this H will be positive. And so that's the symbol for the hydrogen ion when it's positive. So here's what we have for hydrogen. We have hydrogen with this dot. We have hydrogen that's naked with a +1. And then we have hydrogen with 2 dots and a -1. And that's kind of the 3 things that hydrogen can do. Okay. All right, let's look at this one. Draw the Lewis dot diagram for the sodium ion. Okay, so same thing. Let's look on our periodic table for sodium. The symbol for sodium is Na. And it has 1 valence electron because it's in group 1. But look on the periodic table, it's in the same group as hydrogen. So since it's in group 1, we're going to draw sodium with 1 dot. So we're going to draw the Lewis dot diagram for the sodium +1 ion after a neutral sodium atom, which is this. After this neutral sodium atom loses 1 electron. So we're going to pull that electron off. And what are we going to get? We're going to have sodium with no electrons. It's going to be naked and a +1. So that is what we will have. Now, if you want to put a 1 there, that's fine. It's not wrong. But we typically don't put the 1. If we put plus, it means +1. Okay, make sure you hit submit here. All right, number 4, draw the Lewis dot diagram for the chloride ion with a -1 charge. Okay, let's think about this. Chlorine is in group 7, so chlorine is has a symbol Cl, and it's in group 7. And again, you guys don't have to draw this here. I just need to draw the final answer at the bottom. So this is chlorine with group 7. So what we're going to do is we're going to start here. That's 1, 2, 3, 4, 5, 6, 7. So there's 7 valence electrons. You can kind of think of it like this. There is a hole here. There is, I guess we can put it right here. There is a hole there where an electron can go. There's only 1 spot available around here. Remember that the max is 8. And so this chlorine is very close to getting 8 electrons. So if we have a neutral chlorine atom, it's got 7. It looks like this here. And so what we're going to do is we're going to gain an electron, which means we're going to have a dot here. And then we're going to have a -1 charge. So let's write that down here nice and neat. Cl with 4 pairs of electrons. We want a full octet. Remember, octet is the octet rule is the rule that tells us that elements want 8 electrons in the outer shell when they become ions and when they form compounds. So there's our Lewis dot diagram for chlorine. And make sure you click submit. Beautiful. Now draw the Lewis dot diagram for the sodium chloride. So remember we had sodium with the +1, and we had chloride with the -1 and 8 dots. Well, now we're just going to put them together and say there's the Lewis dot diagram for sodium chloride. So that's the answer for that one. Pretty much just those 2 answers put together. And basically there's an attraction here. This is positive, this is negative. Opposites attract, and so there's a little bit of a bond there. We call that an ionic bond. Okay, and remember that these things will form a crystal. So I can have sodium, the plus, chlorine with the minus with its 8 electrons, and then sodium with the plus, and then chlorine with the minus, sodium, chlorine, and that one attaches. And it makes it basically a 3-dimensional shape. And it's going to be this big kind of cubic looking thing. So it's going to make a cube. And that's what we call a crystal. So ionic compounds make crystals. All right, so let's hit submit. And we are done with the warm-up. Okay, so we talked about ionic compounds. Bonds are formed when ions give or take electrons. It's always a metal and a non-metal. Valence electrons are exchanged. An example is sodium chloride. These are usually weaker than covalent. All right, and we looked at some examples of these. Keep in mind on this slide, the last diagram is the Lewis dot diagram. So these are Lewis dot diagrams for for ionic compounds. Sorry. Okay. Now covalent. Now I'm going to switch over to the PowerPoint so that I can write on them and do some things with them. So let me look here. All right, so we did ionic. Now let's look at covalent. So some new stuff. Oops. Oh, and if you click through this PowerPoint that I sent you guys in the chat, let me go back. I clicked too fast. So if you look here, so here's the potassium ion. Here's the potassium atom, the fluorine atom, and what's going to happen is the metal's going to lose it. So there it goes. Oh, I guess I won't show it. Why not? Maybe because I'm not presenting. Hold on. Let's actually present, and it should work. No, I guess it doesn't do it. I don't know why. Okay, but these are examples of ionic compounds. Now let's go to covalent. For covalent compounds, these bonds are formed by sharing electrons. It's only nonmetals. Valence electrons are shared. An example is H2. Another example is O2 or N2 or water, H2O, or CO2. Those are all examples. These are strong bonds. And remember, we're going to use prefixes to do these. So mono, di, tri, tetra, and so on. So let's look and see what happens with these covalent compounds. So here's Cl2, which is called the dichloride. This is the nonmetal. So they're both chlorine. So one atom is chlorine with 7 valence electrons. And here's the other chlorine with 7 valence electrons. What's going to happen is they're both going to grab one of these electrons. And they're going to say, hey, what if I share that one? And then, hey, what if I share this one? So there's going to be 2 electrons shared. Okay, and so it's going to look like this. Chlorine with 2 electrons shared between them. And then they're each going to have their 6 electrons, right? 1, 2, 3, 4, 5, 6. Because they had 7. We took away 1, so they have 6 left. So if you take these 6 electrons, it's now going to have 8, okay? So let's draw a picture around this and count. So here's this chlorine. Check them out. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. He's happy. Now check this guy out. He's now got 8 too, so he's happy. And so what's happening here is each of the chlorine atoms will donate one of its electrons to form a bond between the chlorine atoms. And so now they both have 8 electrons in their outer shell. So it's a mutual benefit. You can also draw this bond like this, with each having 6 lone pair electrons. Actually 3 pair, I guess, but six lone electrons on each chlorine atom. Those are electrons that belong to that atom only and are not shared. But then there's 2 in this line here. So when you draw a line between 2 atoms, it means that there's a bond between them. So they're bonded together, and that bond is 2 electrons. All right, and so this can be another way to draw this Lewis dot diagram. I should be using my pen instead of my mouse, but yeah, so that would be a good Lewis dot diagram of this. So we could draw it that way. We could also draw it this way. You guys can see that there's 8 electrons on both those chlorines. So either of those works. You can draw the electrons between them to show that they're shared. You can even circle them to show that they're shared. Either of these diagrams is fine. Okay, that's chlorine. Now let's look at CO2, carbon dioxide. So carbon's got 4 valence electrons. Oxygen has got 6, and you have 2 of them. Okay, because it's dioxide. And actually, let me get my iPad ready. This will be easier if I use the iPad. Okay, very nice. So let me use a whiteboard here, and let's go through how to determine the Lewis dot diagram for CO2. All right. So we have CO2. Remember that the first step to determine the Lewis dot diagram for a covalent compound is to determine the number of valence electrons. How many valence electrons are in this molecule? All right, well, we have carbon. Carbon is in group 4, so it's got 4. And oxygen is in group 6, So each of those oxygen has 6 valence electrons. Now we are going to have to multiply that by 2 because we have 2 oxygens. So that's 12. So we're going to add the 12 and the 4. We get 16. So we will have 16 valence electrons in here. We're going to have to pick a center. So the second step is to pick a center. The center atom, well, in this case, we only have one carbon atom. So we can just say, okay, carbon's going to be in the center. Oxygen is going to be out on the outside. So if you only have one of those atoms, it will usually go in the center. Not always, but you guys can go ahead and just assume that. If it's only got one of that element, it'll go in the center, and that's fine. Carbon also goes in the center because he needs more electrons. He has 4, right? Remember, he had 4. Oxygen has 6. So carbon has 4. Therefore, he needs 4 more to get to 8. So he needs electrons more than oxygen. So whichever atom wants electrons more will be in the center. Okay, also, carbon is less electronegative than oxygen. Carbon is less electronegative than oxygen. And so that means carbon is further away from fluorine. Remember, fluorine is the king of electronegativity. And as you move away from fluorine, you get less electronegative. So carbon is less electronegative. And the rule is that the atom that is least electronegative will go in the center. So that's another reason why carbon will go in the center. All right, so now we're going to take our 16 electrons, and we're going to place them around our atoms. So we're going to start with carbon. He's got 4 of his own. Oxygen's got 6. Okay. And then let's kind of look at this. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16 electrons in that picture. We're going to want to bond them together. So we're going to go ahead and actually erase these 2. And we're going to put them between them. Okay, so 1, 2, 3, 4, 5, 6. I guess that would be 1, 2, 3, 4, 5. I'm going to put that one there. And then I'm going to erase this one and erase this one. And I'm going to put those there. So that'll make a bond between those atoms, okay? And so let's look for the octet. Let's look at this guy. 1, 2, 3, 4, 5, 6, 7. Not happy. A single bond will not work. These are shared. All right? Now let's look. So basically, what we're going to need to do is donate more electrons. All right? So oxygen is going to have to take this electron and donate it to the bond, and then carbon's going to need to take this electron and donate it. So let me show you what happens when we do that. So now we've got carbon in the center, oxygen over here, oxygen over here. We're going to need 4 electrons between both of those in order to make an octet. So that accounts for half of our electrons. There's 4 more. Oops. And there's 4 more. So if we look at this, now let's check for octet. That one has 8. He's happy. This one has 8. He's happy. And this one has 8. He's happy. So this is the Lewis dot diagram for carbon dioxide. And we can draw it another way. Instead of drawing the dots, we can draw the lines. So we can draw it this way. Oxygen, double bond carbon, double bond oxygen, and then 4 dots left over on each of those oxygen atoms. And so that's my favorite kind of version of this Lewis dot diagram. But it has to be double bonds because that's the only way you're going to make an octet. You only have 16 electrons to work with, and you've already used them up. And so if you find yourself unable to make an octet for one of the atoms, one or more of the atoms in the compound, then you need to donate more and make a double bond. Okay. All right, and then this is what this would look like. Here's another example, water. Water has 8 valence electrons, 1 for each of the hydrogens and 6 for the oxygens. And so hydrogen will share 1 with the oxygen. So oxygen has 6. It needs 2, so it's going to share 1 electron with each of those hydrogens. And so if you look in this blue circle, you'll count and see that there's 8 valence electrons. And then look at the hydrogens. Each has 2. Remember that hydrogen follows the duet rule, which means that hydrogen wants 2 valence electrons, not 8. And so there is our Lewis dot diagram for water. And I'm going to draw it a little nicer here. H-O-H with 4 dots left over. So that's the Lewis dot diagram for water. That way we use up 8 electrons and we have an octet on the oxygen and a duet on each of those hydrogens. Wonderful. All right, let's look at CH4. This is what that would look like, and I'll draw you guys a picture of this as well. CH4 would look like this. H, C, H, H, H. So there's 4 H's around it. No dots, because carbon has 4 valence electrons. He needs 8. And so what he's going to do is he's going to share 1 electron with each of those hydrogens, which means that all 8 electrons are involved in bonding, because there's 4 pairs of electrons used to bond with those hydrogens. So all of the electrons are used in bonding. So when you draw your picture, you will not have any dots on it. So carbon has an octet here. If you look at this, let's draw a circle here. Actually, I'm just going to let the animation do it. So look at this purple circle. There's 8 electrons in the carbon. And remember, they're all bonds. So if you wanted to, we could draw a line connecting them, showing the 4 bonded hydrogen atoms. And then look at each of these hydrogens. They all have 2, so they're all happy. Now let's look at O2. Oxygen's going to need double bonds because you're going to need to get, you've only got 12 electrons to use. This oxygen is in group 6, and so 6 times 2 is 12. So you have 12 electrons to work with, and let's try to connect them. So if I have 6 electrons, excuse me, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So basically you can see that I had to add these 2 on this one, and there's a hole here. So you can see that there's not enough electrons for both of them to have an octet. So let's count. This one has 8. So he's happy. He's got an octet, and it looks like a donut, so it's kind of funny. So when you guys go home and talk to your parents, what did you guys learn in chemistry today? Tell them you learned how to draw Lewis dot diagram donuts. Okay, and then let's look at this one. 6. It's not equal to 8, and so he's not happy. And so if you just use these 12 electrons and draw a Lewis dot diagram with a single bond, with just these 2 being shared, it doesn't work. Both oxygen atoms are not able to make an octet. So what we're going to need to do instead, just like we did with CO2, so we're going to need to have a double bond between those oxygens and then have the remaining electrons around. So remember, we only have 12 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 in that picture. And then let's check our octet. 8, he's happy. 8, he's happy. So but we need a double bond here. So oxygen double bond with 4 electrons left over, and that will be our Lewis dot diagram. Isn't that nice? Double donut. Okay. What else we got? Here are some other examples, if you guys want to look at them, of ionic bonding showing the transfer of electrons. Now, the only thing I don't like about these is they're not showing the charges after. So I don't really like these. And I'll add the charges just so it's complete. So that's going to be a +1, -1, -1, +2, -1, +2, -2. So if you want the charges, there they are. Y'all don't need to do anything with these slides. They're just notes kind of added in. And then this one as well. Let me draw the charges. That's a +1, a -2, +1. That's a +3, and each of these is a -1. So there's the charges, just so you guys know. Okay. Here's the covalent bonding example of hydrogen. So let me draw these 3 Lewis dot diagrams for you guys. Hydrogen will look like this. Fluorine will look like this. Now keep in mind, fluorine has to follow the octet rule. So notice that when we do hydrogen, it's just H-H, and there's no dots. And that's because there's 2 electrons in that bond, and hydrogen requires 2. So if we look at this hydrogen, he's got 2. If we look at this hydrogen, he's got 2. So they're both sharing those 2 electrons. So those 2 electrons effectively are owned by both of those hydrogens, and so they meet their duet rule. They both have 2, and so it's just H-H, and that's our Lewis dot diagram, no dots. Now fluorine and every other element on the periodic table, except for maybe helium, is going to want 8. And so you have to make sure that you follow the octet rule for these, so that they're going to have 8. So F2 will have 7 times 2, which is 14. So we're going to have 14 electrons in our picture, and there it is. And then O2 will look like this. Double bond with 4 dots left over. That'll be our Lewis dot diagram. Okay. So we want to be able to match these up. We want to be able to fix ones that are not correct. And we want to understand how to make these Lewis dot diagrams. Here's nitrogen. Nitrogen requires a triple bond, which is kind of cool. So I'll draw these 3 here. So we have N2, which looks like this. N triple bond, and then you're going to have 2 dots left over. So that's 10 valence electrons. All right, because each of those nitrogen is in group 5. All right, this is CO2. We already showed you guys that one. Looks like this. Looks a lot like the O2 molecule, but with the carbon in the middle. And then water looks like this. Okay. We are almost done here, guys. Let's see. Let's look at the Nearpod. I think I had some stuff on the Nearpod. So let's continue through the Nearpod all the way to the end. Excuse me. I did put the video in here just for reference. This is not the video quiz. It's just the YouTube video. So it's the same video that we're going to do for the video quiz, which is kind of like an Edpuzzle. But this one is just in here to watch just as a reference. So I just put it in there. Felt like it needed to be in the Nearpod. So here we're going to draw the Lewis dot diagram for CH4. So let's go through that. CH4. It kind of cut off there, so that's the formula for the molecule. So I'm gonna put first I'm gonna count valence electrons. Carbon is in group 4, so there's 4. Hydrogen is in group 1, so I'm gonna put 1. And now I do have 4 of those hydrogens, so I'm gonna multiply that by 4. So I have 4 electrons from carbon and 4 electrons from the hydrogens, so I have a total of 8 valence electrons. So my picture has to show 8 valence electrons. I'm gonna determine a center. This time, I'm going to put carbon in the center, and that's because hydrogen can never go in the center. I'm going to put hydrogens on the outside. Hydrogen always goes on the outside. And I'm going to put dots shared between them to make a bond. And there you have it. I drew 4 pairs, which is 8 electrons. So there's my picture. All done. Now, I will show you guys another way to draw this, so that if you see it on the exam, you'll be familiar with it. So we can draw the line drawing as well. It's the same thing. Remember that each of those lines is 2 electrons shared between those atoms. Okay. All right. Make sure you hit submit there. And then go to the next one, CO2. CO2 is going to look like this. We talked about this one several times. 4 plus 12, so that's 16 valence electrons. And so I should have 16 in this picture. 1, 2, 3, 4. Let's check. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I have 16. There's our picture for CO2. Awesome. Okay. Hit submit. And if I'm going too fast, just go back. Now, briefly describe what you learned today in class. So I showed you guys how to draw a Lewis dot diagram for covalent compounds. We talked about practice ionic compounds. We talked about following the octet rule, the duet rule. We talked about counting valence electrons. We showed you 2 different ways to draw these Lewis dot diagrams, both with the bonding and the and all the dots. So lots of things. So make sure you put something here. Click submit, and that's the last slide. Here's a slide here that just has the assignments. So now the last thing I need you guys to do is to watch the video quiz. And so let me show you that. So if you click on the link in the Google Meet, there's a video quiz, which is right here. If you click on that, it will take you to a slide that looks like this. and it'll say Start Quiz. So you click that blue thing there. And so there's some questions here. So open it, and then make sure you watch the whole thing. I did label the questions here, so you should be able to see where they're at. But if you can't see where they're at, make sure that you watch the whole video, because I don't want you guys missing any questions. Because if you miss a question, it'll count it wrong. All right, and so what I need you to do is click play, and then you get this toolbar by going down to the bottom. So if you like go up, it'll disappear. But if you go down to the bottom and just kind of move your mouse down there, this toolbar will show up. And so you can hit play, and you can click on the first one, and you can go to the first question. All right, so answer these questions. There's only 12, and I'll answer them in class. I'll put them in the chat. And so answer these questions. Just like an ed puzzle, after you answer all the questions, it automatically saves. But one better, it also puts it in Canvas. So if you go to your grades and you go to the video bonding quiz, which is going to be in here somewhere, covalent bonding quiz, you should see your grade there. All right, so it should grade that for you. All right, guys, make sure you guys turn in your Nearpod. Make sure you have that all done. I'll be kind of checking to see who's got that done in class so you can get your points for today. Remember that in-class participation grade is a test grade, and so that's the greatest factor in determining y'all's grades is, are you doing anything during class? And even if it's not during class, especially if you're virtual, if you get the stuff done outside of class on the same day, then that's fine, okay? And so we're trying to be flexible, so that if you're watching a sibling or something and you have some time later to work, then you can do it later, okay? But I think some of you guys are taking that a little too far, and you're not doing some of the work or most of the work, some of you guys, and you've got to catch up, all right? Because we're getting close to our grading things, and I've updated grades, so grades are pretty much locked in. You guys just need to turn in that stuff. And let me know when you turn stuff in, and I'll make sure I get it graded, and I'll work with you guys. All right, I've been putting answer keys for some of these assignments. Like if you go back to our classworks, like ionic, transition metal classwork, polyatomic classwork, all three of these, the answer key is in there. All right, so you just need to go down and click on, not that one, not ionic bonding. This one I will put the answer key in there, but it's not in there yet. Ionic classwork. Where is it? Ionic classwork. There we go. So if you click on that one, answer keys right here, guys. All right, and I think it's four pages. All right, so type those in, submit assignment. Okay, make sure you turn it in on Canvas. All right, guys, thank you so much. Y'all have a great rest of your day.